Welcome to section 13.1. We're dealing with trigonometry of right triangles. Now, majority of this section will be a review from geometry, but we are going to add a few new things in, and so I want to discuss those as we go through. Let's start with the three basic trig functions that we know that you learned in geo. The sine, and I'm going to write it out so you see it, the sine of an angle is opposite over hypotenuse. Now remember please that this is all talking about a right triangle. We have this angle down here. If we label our sides, we know the hypotenuse is always the side across from the 90-degree angle, or the longest side. The opposite is when you take your angle and go directly across from your angle. This is the opposite. And the adjacent is the side that's directly next to the angle. Okay, so we're writing ratios of sides, fractions of sides. So the sine of this angle theta is the opposite side divided by the hypotenuse. Okay, the cosine of that angle is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And we gave you a phrase in geometry to remember that. We said, call it SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, you'll hear it both ways. But it's this idea that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And so this is the idea, and I'm going to give you a different phrase for that as well as we're going up. Now what you may not have known from geometry is you have what we call reciprocal functions. And these reciprocal functions, reciprocal means basically you flip the top and the bottom. They just take this and flip the hypotenuse and the opposite. Now this is cosecant. And actually, let me erase that because I wanted to write it out. This is cosecant. Okay, and we want you to know the words, cosecant. It is the same thing as flipping the hypotenuse now over the opposite, or we write it as 1 over the sine of our angle. Okay, the second one is secant. And secant is the hypotenuse over the adjacent, or the same thing as 1 over a cosine. The third one is called a cotangent. It's the reciprocal of a tangent, so 1 over tangent. Or we look at it as the adjacent over the opposite. Now, we are going to be using these more so in terms of trig ratios than other things. But if you're thinking about pre-calc, these will become a daily thing in pre-calc, so kind of, again, ask questions as you go through. Now, this phrase, SOHCAHTOA, know it, learn it, memorize it if you don't already have it. We give you a phrase, and what I don't know is if you've heard it in geometry. Let me put a disclaimer on this already. It is not politically correct, but it works, okay? So here's the way it works. We say, some old hippie caught another hippie tripping on acid. Again, I'm going to disclaim that not maybe the most appropriate, but it works. Some old hippie caught another hippie tripping on acid is the way that we sometimes remember SOHCAHTOA. It's this idea that, again, it will help you remember the ratios. And so that's the first part. Now we're going to use these trig ratios to help us then evaluate some functions. So let's slide down. All right, as we go through, in this first one, we give you this triangle with sides 8 and 15. In order to use the trig ratios that are here, the 6 trig ratios, what we need to do is be able to find the third side. Well, in order to find the third side, we use Pythagorean theorem. So 8 squared plus 15 squared is our hypotenuse squared, and we normally say ABC. 8 squared is 64. 15 squared is 225, so this ends up being 289. And in order to get c squared, we square root it. And if we square root it, we get 17. So the hypotenuse of this triangle is 17. Now I'm going to label my sides as well. And I always start with hypotenuse, and then I go across my angle to the opposite, and then I go down to the bottom to get my adjacent. Okay, so let's do sine. Sine is the opposite over the hypotenuse, so 8 over 17. I'm going to go across. Cosine is the adjacent over the hypotenuse, so 15 over 17. And lastly, tangent is opposite over adjacent, so 8 over 15. Okay? Now as we look at it, now we're going to do its reciprocal. Cosecant is the reciprocal of a sine, so it's now 17 over 8 because we flipped the top and the bottom. Secant is the reciprocal of a cosine, so it's 17 over 15 as we flip our fraction. Third one, cotangent is the reciprocal of a tangent, so 15 over 8. Okay, for the most part, this is going to be really nice. One of the big things, though, in these ratios, there are no decimals for ratios. That's huge. What that means is if you get a decimal answer, you have to instead have a square root. So we're going to be breaking down square roots this chapter as well. Okay? Now, we're going to use this, and I'm actually going to slide this down a minute because I want to do this number 1 first. Let's take a look at this. I'm going to put my theta down here, and I'll come back to the one above. This is my angle. Sine is opposite over hypotenuse. So opposite is 4. So straight across is the opposite. Hypotenuse is 7. I need to know this other side, my adjacent. So in order to find the adjacent side, I use Pythagorean's theorem. 4 squared plus this other side squared, I'm going to call it a squared for adjacent, equals 7 squared. 4 squared is 16. So when I subtract 16, I get that a squared is, let's see, 7 squared is 49, right? So 49 minus 16 is 33. And if I square root this, I get that a is the square root of 33. Now, 33 cannot be broken down because you can't divide it by your perfect squares. 4, 9, 16, 24, or 25, 36. None of those go in there, okay? So I'm looking here. Now, as I go through, I want to look at these. So I have this side is the square root of 33. If I want to find the other ratios, here's truthfully what I do. I start like this. Sine, cosine, tangent, and then I do its reciprocal. Sine goes to c, so cosecant, secant, cotangent. Okay, and I want to write these ratios. All right, so here we go. Sine we did already, 4 over 7. Cosine is the adjacent over the hypotenuse, so the square root of 33 over 7. Tangent is opposite over adjacent, so 4 over the square root of 33. The only problem is we cannot leave a square root in the denominator. So what we're going to do is multiply by the square root on top and bottom. We called that rationalizing in chapter 8. Or chapter 5, as we look at this, we have 4 square roots of 33, all divided by 33. Now, if 4 and 33 could reduce, you should. Otherwise, there's my answer. All right, cosecant flips a sine, so 7 over 4. Secant flips a cosine, so this is 7 over the square root of 33. And again, we're going to rationalize this, and I'm going to try and save myself some room. You end up getting, let me move this over. You end up getting 7 square roots of 33 over 33. And 7 and 33 can't reduce, so this is the one I keep. Okay, last one. Cotangent flips the tangent. Now what I'm going to do is not use this one. I'm going to go back to this original one right here, and I'm going to flip that. So the square root of 33 over 4. And it's always better to go back to the original before it's rationalized to make sure then that you don't have to mess with dividing things, fractions, whatever else. Okay? Now, so this is the idea. If I give you one trig value, you can find the other 5 by drawing a triangle and labeling all 3 sides. So let's go back to the top part again. We want to solve this, and we're going to talk about, this is the idea in geometry again. And so we're going to go back to geometry. Now in this case, we're probably going to get some decimals, but before you do anything, please change your calculator into degree mode, so that your mode is right next to the delete button. It's right at the top left area. and it should be on radian. Go over and switch it to degree, because if you're not in degree mode, you will get the wrong answer. Okay? Now, what I'm going to do is I'm going to start by finding, doesn't matter which one, but I'm going to start by finding side C. Okay, I'm going to start here. So in order to find side C, I'm going to use my angle and my side. Now I'm going to label my sides a sec. This is the opposite, this is the hypotenuse, and this one's the adjacent. Okay, so if I am trying to find C, I have the adjacent and the opposite side that I'm going to use, which means I'm going to go to cosine, because cosine uses adjacent and hypotenuse. So I'm going to say the cosine of my angle is 13 over my hypotenuse, which is C. Okay, now I'm going to get C out of my denominator, so I have C times the cosine of 56 equals 13 now, because these cancel out. And if I divide by the cosine of 56, then I'm going to get C by itself. Now this you put in your calculator, 13 divided by the cosine, and I believe it puts a parenthesis, so close your parentheses. And what you should end up getting is about 23.25. Okay, so 23.25. All right, let's find side B this time. And in this case, here's what I'm going to do. I'm going to change the color so you can kind of see my work a little differently. I'm going to use the 56 again. I'm going to use the 13, but now I'm going to use the opposite side. So the question is, what trig value uses adjacent and opposite? Well, it's tangent. So I'm going to take the tangent of 56 equals adjacent over opposite over adjacent, right? So B over my adjacent side is 13. So I'm going to multiply both sides by 13. That'll get B by itself. B ends up being about 19.27. Okay, one last thing we haven't done. We don't know what angle A is. Well, let's talk about the angles in a triangle. All three angles in a triangle add up to 180. So if I'm trying to find angle A, I take 180 minus the 56 they gave me, minus the 90 degrees for the right angle, and I end up getting 34 degrees. So angle A is 34. This is the type of work we're going to ask you to do in this section. 1, write ratios. 2, actually find angles, find side lengths, things like that. Okay? All right, let's flip the page. Okay, number 2 says solve triangle ABC. Okay, if you need this know and the needs idea, you can. It's up to you. I'm just going to do it just to make sure I know. But I know angle C is 90 degrees, right? I know that angle A is 37 degrees, and I know that side C is 22. Okay, so what do I need? Well, let's start off. I have 2 angles. Let's find the third angle. In order to find angle B, I know that angle B is 180 minus the 90 minus the 37. Therefore, angle B is 53 degrees. Okay, I'm going to change my color. Let's do another thing. What's another thing I need? Let's do side A first. So if I need to find side A, I know angle is 37, side is 22. But I need to know what sides I'm working with, so I'm going to label my triangle. 22 is the hypotenuse. A is the opposite because it's directly across from the angle given to me. So that means B has to be the adjacent. And this is, again, the way I always label the sides. Hypotenuse first, opposite second, adjacent third. Okay, so if I'm looking at this, I need to use the opposite and the hypotenuse and my 37. Well, opposite and hypotenuse is sine. So I'm going to take the sine of 37 equals the opposite, which is A, over the hypotenuse, which is 22. We multiply by 22. Okay, once I take the sine of 37 and multiply it by 22, you should get that A is about 13.24. And I would always round probably 2 decimal places just to be on the safe side. Okay, let's change our color one more time. Let's do our last one. What are we missing now? Side B. B is the adjacent, 37 is my angle, 22 is the hypotenuse. So what uses adjacent and hypotenuse? Well, that's a cosine. So the cosine of my angle 37 is the adjacent, which is B, over the hypotenuse, which is 22. So I multiply both sides by 22. Side B is approximately 17.57. Oops, side B, 17.57. Okay. Now again, I'm color coding, so as you look at this, you can see my work. Please don't feel like you have to, but this is kind of a nice idea as you're going through. Okay, we've got a couple of story problems, and then we'll be done. Take a look. I'm going to start with these two. We're going to start first with the angle of what elevation we're called. You are measuring the height of your building if you stand 25 feet from the base of your school. Okay, I'm just going to start here. Here's my school. Not what a school looks like, but go with me. If I stand, here's the base of the school. If I stand 25 feet away, this is me, okay? The angle of elevation from the point where I am on the ground to the top of the school, so from where I am to the top of the school, this angle that it makes is 62 degrees. Estimate the height of the school. I want to know how tall my school is. Can you see my right triangle? Now, as I look at my right triangle, I want to talk about what sides of the triangle I have. Well, the height is then going to be the opposite, and the distance I am away then is the adjacent. So what trig value uses opposite and adjacent? Well, that's tangent. So the tangent of 62 is the opposite, which is x, over the adjacent, which is 25. We multiply both sides by 25. Now they want my answer to the nearest foot. So when I plug this in my calculator, the height of the building is approximately 47 feet tall. Okay, you need the feet because you're talking about a picture, something that has a relevant piece to it. So you do need the label of feet. Okay, so that's the first one. Second one, we're going to talk about the angle of depression. Well, an airplane is traveling at 25,000 feet above the ground. All right, here we go. We have an airplane. An airplane is 25,000 feet above this ground. Here's the ground. Okay? As it begins to descend towards the runway, it's going down, right, towards the runway. Here's where my runway starts. The angle of depression, the angle it goes down, is 15 degrees. Now, that assumes if the plane continued, it's going to start decreasing. It's going down 15 degrees. So it's not this big angle here. It's the small angle that comes down. Now, what I know from geometry is that because it's cut here, this is 15 degrees, so this is also 15 degrees. So now let's make my triangle. It's a right triangle. I want to know how far away from the runway. That's distance here. How far distance away from the runway is it? Not how far does the plane have to go. It's not this distance. It's the distance right down here. How far away from the runway? Well, let's talk about sides. Here's my angle. So the 25,000 is the opposite. The x is my adjacent. So we just said opposite and adjacent was a tangent. So the tangent of 15 is the opposite 25,000 divided by x. So I multiply both sides by x. X times the tangent of 15 is 25,000. And when I divide by the tangent of 15, I end up getting, again to the nearest foot, I end up getting about 93,301 feet away. Okay. again, drawing pictures. Do not try and do this without drawing a picture. Okay, last one. We're talking about a flagpole or a building. From the point on the ground, 28 feet from the base of a flagpole. All right, I have a flagpole. From the base of it is 28 feet away. The angle of elevation to the top of that flagpole, the angle of elevation, meaning from the ground up, is 63 degrees. Find the height of the flagpole. I've helped you with the picture. You show me your work in order to get the notes points, okay? Now, second thing, you also tonight have to watch the video on exact trig values for the unit circle. So that's the second piece, because that exact trig value is part of what's on your homework for 13-1. So tonight, finish this, okay? Finish this question for notes points. And watch the next unit circle video on exact trig values. Okay, again, we're going to start off tomorrow's class like we did today with the unit circle warm-up, so just kind of be aware of that. Thanks for watching.